So today we are going to see philosophy of engineering. So the unit 1 is Introduction to Philosophy of Engineering. So engineering, we can define it as a profession, or it is a discipline of applying technical and scientific knowledge, and we can also utilize the laws which are available in nature and physical resources which are available, and using these we have to design and implement materials or structures or machines, devices, systems, or and meet specified criteria. So the American Engineers Council for Professional Development has defined engineering as creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes or works utilizing them in combination or single also to construct or operate the same with full cognizance of their design. Otherwise, to forecast their behavior under specific operating condition, all as respects an intended function, economics of operation and safety to life. So engineering as such can be defined as building a process. So we can call building of a process, manufacturing a process, or building a process, designing an object under specified condition, and at the same time we have to keep in mind the safety of life and property. So now anyone who practices engineering is called, so after obtaining a formal degree, anyone who practices engineering is called an engineer. And those who are licensed to do so have more formal designations such as European engineer, professional engineer, chartered engineer, or incorporated engineer. Now engineering doesn't confine to a single field, but it comprises of broad disciplines of fields. So we have electronics and communication, computer science, chemical, mechanical, architecture, and so many other disciplines. So all these come under engineering discipline. Next, we will move on to a more interesting topic. What is the history of engineering? So what do you think? How engineering evolved? How did it start? Okay, so let us see that it has existed since the ancient times, because human devised fundamental inventions such as pulley, lever, wheel. These are all existing from the ancient times, and then each of these inventions is consistent, or it is available with modern definition of engineering. Exploiting means we are utilizing or we are employing the mechanical principles only. Most of the principles initially used were mechanical principles, and these were utilized in a way so that they can develop useful tools and objects. So as we see here, the engineering has a recent etymology. However, the word itself dates back to 1325. Okay, very long back. So the one who operates an engine was called an engineer. All right. So the word engine is also having a very old, significance. It started in 1250. That means innate quality, especially mental power and a clever invention. Now with the design of civil structures, that is some of the civil structures are bridges, civil engineering entered the lexicon as a way to distinguish between those specialized in construction of non-military projects and those involved in older discipline of military engineering. So we cannot imagine any of the era where military engineering was not available. Similar to that, non-military projects were also being done in parallel. So right from the olden days, we know that military was dominant, or it was existing. So whenever we talk about military, we know that so many engineering devices or tools or equipments had to be designed. At the same time, non-military projects were also available from a very long time. So we can observe some of the structures that were built during the ancient era. So when we say ancient era is actually a prehistoric era, and it actually ends by 700 AD. So can you observe these structures, how they were built, and they are all by themselves. They have required a huge amount of intelligence to build these structures. This is an example of Acropolis and Parthenon. So the Roman aqueducts, we can see these structures, how they are well planned and built. And this is Via Appia and Colosseum, and this is the Hanging Garden of Babylon, which is very popular. And this is Pharos of Andria, and the pyramids in Egypt. If you observe closely, you can see that a lot of intelligence and lot of human power has been utilized to build these, and they belong to the ancient era. So it is so surprising that at that time such buildings have existed. And then again we see a continuation of the ancient era. The earliest civil engineer, he was by the name of Imhotep. You can see, observe that civil engineer here, and he was one of the officials of Pharaoh, and he probably designed and supervised the construction of step pyramid at Saqqara, Egypt in 2060. 2630 to 2611 BC. So we can see that before AD itself, these structures were built. The pyramid was built before AD, and this is what the pyramid or the step pyramid looks like. And he may also have been responsible for the first use of columns in architecture. We can see a columns in the building, and he is the person pioneer for columns in building of architecture. So we observe that Archimedes was responsible for introduction of this Antikythera mechanism, the earliest known model of mechanical computer in the history. And mechanical inventions of Archimedes are the earliest examples of mechanical engineer. So he could be called as the pioneer for mechanical engineering. And invention of these machines required. So here we can see the Antikythera mechanism. These machines actually involved or required sophisticated knowledge of differential gearing or epicycle gearing, two key principles in machine theory that help design the geared trains of industrial revolution. And Chinese and Roman armies employed complex military machines including ballista and catapult. So ballista and catapult, as you can observe here, ballista and catapult, these were developed by Chinese and Roman armies, and they were employed by Chinese and Roman armies. So the next era, what we see is the middle era. So in the middle era, who played an important role is Al-Jazari. He has played an important role, and the duration of middle era is between 1174 to 1200 years, and he built 5 machines to pump water for the king. So he is the very first person. Al-Jazari is the first person, an Iraqi engineer who had introduced automation in engineering. So he developed these water pumps which were used during the kings of Turkish Artiquid dynasty in their palaces. So he even built a peacock structure which will give water by itself. Through a rotating pipe, it will give water by itself. So he had converted the double acting reciprocating pistol pump was instrumental in later development of engineering and in general, because it was the first machine to incorporate both a connecting rod, we can see a connecting rod, and a crankshaft, thus converting rotational motion to reciprocating motion. So he was the mechanical engineer who found out that rotational motion can be converted into a reciprocating motion, and he built totally 5 structures. And the next era is Renaissance era. So in Renaissance era, some of the new or some of the important fields of engineering have emerged, like electrical field. So electrical field was first developed by William Gilbert in his publication at the time of 1600 in De Magnete. He was the originator of the term electricity. So now we cannot imagine a life without electricity. So William Gilbert is the person who initiated this electricity. And the first steam engine was built in as early as 1698 by mechanical engineer Thomas Savery, and the development of this gave rise to industrial revolution. In the later decades, we had industrial revolution with mass production of so many equipments and inventions, and this is the pioneer or the engineer who started this industrial revolution was probably Thomas Savery. So they are both William Gilbert and Thomas Savery are two important pioneers in electrical and mechanical engineering. Now, with the rise of engineering as a profession in the 18th century, the term applied to fields in which mathematics and science were applied to these. So in addition to military and civil engineering, there existed mechanic arts that also was incorporated into engineering. So this is one Renaissance era. The next one is modern era. Modern era is very important because electrical engineering originated because of Alexandra Volta in 1800s, and experiments of Michael Faraday, George Ohm and others led to the invention of electric motors as early as 1872. So we can see them here: Alexandra Volta, George Simon Ohm and Michael Faraday. And we see James Clerk Maxwell and Henrik Hertz. They in the later 19th century gave rise to the field of their inventions, or their works gave rise to the field of electronics. So once the field of electronics emerged, we had the vacuum tube, which is considered to be the first transistor ever in the history of electronics. And then this accelerated or helped the development of electronics to such an extent that electrical and electronics engineers currently somewhat outnumber the other field, because we know that without electronics and without electricity, any other field cannot exist. Even if it is a mechanical field or if it is a software field, there is a need for electricity. So in modern era, the electronics and electronics field originated, and these scientists are pioneers for the field of electrical and electronics. So similarly, in the modern era, the invention of Thomas Savery and James Watt, the Scottish engineer, this gave rise to the modern mechanical engineer, and development of specialized machine and their maintenance tools, everything which during the Industrial Revolution led to the growth of mechanical engineering, both its birthplace, Britain, and other countries as well. So continue. This is how the Industrial Revolution looked like. So chemical engineering. Chemical engineering is supposed to be a part of mechanical engineering. It is a like its counterpart, mechanical engineering, developed in the 19th century. So in the modern era, we have seen that electrical and electronics engineering originated, mechanical engineering originated, and chemical engineering originated. That is, chemical engineering originated during industrial revolutions. Industrial scale manufacturing demanded new materials and new processes, and by 1880 the need for large scale production of chemicals was so much that a new industry was created dedicated to the development and large scale manufacturing of chemicals in new industrial plants. The role of chemical engineer was the design of these chemical plants and processes. So these plants and processes were required to further development of engineering because of the requirement of mass productions, new engine. So the last part of modern engineering is two different fields are introduced, which are basically aeronautical engineering and aerospace engineering. So what's aeronautical engineering? Aeronautical engineering deals with aircraft design, whereas aerospace engineering deals with spacecraft design. Okay, so these are the two modern era inventions or findings: aeronautical and aerospace engineering, leading to aircraft and spacecraft design. So we can trace its origin to 19th and 20th century by the work of Sir George Cayley. Early knowledge of aeronautical engineering was largely empirical, with some skills and concepts imported from other branches. Definitely for these two fields to develop, knowledge of mechanical and electrical engineering is mandatory. So only a decade after successful flight by Wright brothers in 1920 saw the extensive development of aeronautical engineering. So these George Kelly and they are Wright brothers. So they are responsible for the development of aeronautical engineering through the development of World War I military aircraft. Meanwhile, research to provide fundamental background science continued by combining theoretical physics with experiments. So still research is continuing. Still we are working on theoretically, we are calculating, we are solving problems, and then we are checking whether the theory is mapping with the simulation or with the real-time experiment. So that's how engineering is developing. In the next class, we will continue with the different methodologies or in engineering. Thank you.